Hi everyone and welcome to a new video. Today I'll try to build my first AI neural network, which will be an ape image classifier. To do this, I'm going to be using the idle Jupyter notebook and the image dataset from Kaggle. You have all the links below in the description. But before we start, let's see what our neural network will look like. First of all, we need to apply some convolutional layers. These layers will basically transform our original image into a sequence of simpler images called filters that will be able to recognize different patterns from the main image, such as an eye, a mouth, or the monkey's nose. And then we are going to take those filters and introduce them into a multi-layer perceptron network that finally will tell us what class the original image belongs to. This has been a really quick explanation about neural networks, but if you are interested and you want to learn more about the topic, I strongly recommend you to visit the .csv channel, where you can find tons of content about artificial intelligence. If you don't know Spanish, you can turn on the subtitles, but believe me, it is worth it because it's a very good source of knowledge. Okay, so now we have our first development plan, we can start coding. So let's go with it. The first task is to create the dataset in order to train the neural network. For this, first I've created a function that takes all the images passed and assigns them their corresponding class. These classes or labels will be vectors, where the vector 1000 corresponds to the first class, the 01000 to the second class, and so on. Then I shuffle the data to avoid an overfitting. This happens when the neural network memorizes the training examples, and when I pass it the validation images that has never seen, it gets bad results. Finally, I split the data into the input and output subsets and transform them into Python lists. I need to do this because later I'm going to use the TensorFlow API to load the datasets, and I need to pass the input and outputs, and both of them must be Python lists. As you can see now, I am defining the image preprocessing functions that will reshape, normalize, and augment my data. The last function, called random jitter, is used for data augmentation, and what basically does is take an image, resize it to a bigger dimension, and then take a random crop of it. Then I change randomly the contrast and brightness values. So every time I apply the random jitter, I obtain a totally different image from the original one. After all, I create a function to load the images and apply the transformations, and I create my dataset using the TensorFlow API with TensorFlow data from tensor slices. Then I apply the corresponding function using the map method, and I also shuffle again the data using the shuffle method. Here I'm going to stop a little bit to explain one thing that initially confused me, and I think it is relevant for you. So the map and the shuffle methods are applied every epoch of the training. The epochs are the times I'm going to repeat the training in order to improve the neural network accuracy. So with only these two lines of code, the data will be shuffled and augmented each time, which it is cool for better trainings. Okay, now it's time to build the architecture, so I'm going to start importing the keras and keras.layers libraries. After that, I'll create a couple of Keras custom subclasses. These subclasses are like blocks of simpler layers that allow you to repeat the same layer's operations in one line of code and have everything better organized. As you can see in my convolution class, first I apply a 2D convolutional layer, then a batch normalization, a relu activation, and finally I return a max pool 2D. Moving forward to the dense class, you can see that I added a parameter to optionally apply a flatten layer. This is because the output of the convolutional layer is in 2 or 3 dimensions, while the dense layer only accepts inputs of 1 dimension. So between the convolutional and the dense layer, I need to transform the data using a flatten layer to convert the 2 or 3 dimensions to 1 dimension. Once the subclasses are created, it's time to define the model, for which I've used a Python class again. As you can see in the code, first I'm going to apply a convolution block of 64 filters, then another convolution block of 128 filters, and a third convolution block of 128 filters again. After that, I apply a dropout layer with 0.2 probability and a dense block of 200 neurons and apply flatten true. Finally, I return a dense layer of 10 nodes, 1 node per class, and a softmax activation function. Next, I declare the model and I compile it with optimizer Adam and the categorical cross entropy loss function. The last step is to train the model. So let's see what we obtain. Well, as you can see, the training did not go very well, but let's experiment a little bit and change some parameters in order to improve those metrics. The first change I've made is at the random jitter function, where before I had a mistake and I copied back the probability values, but now those are the correct ones. The next change is in the batch size, now is 16 instead of 20 before. If we move down, I've also changed the kernel size of the comp2D layer at the convolutional block, which now is 4x4. Finally, the second convolutional block is now 64 filters and the dense block is 300 nodes instead of 200 before. So with these corrections, let's train the model for 25 epochs and let's see what the results are. As you can see, the new model achieved an 81% of accuracy in the training set and a 72% in the validation images, which is pretty good. I know this can be improved and the gap between the training and the validation sets should be closer, but to be my first neural network, I'm quite satisfied with the results, so I leave it here. I hope you liked the video. If that, remember to subscribe, give a like and leave a comment below. See you in the next one.